Hello and welcome to our virtual Lunch and Learn today. We'll be talking about Rockwell Automation's ArmorStart product family, variations, and troubleshooting. My name is Rachel Green and I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today will be Eric Dixon, Systems Engineer out of our Madison Heights, Michigan location. Out in the comment section, ready to answer your questions, is Carol Weber, Technical Consultant, also out of Madison Heights. And we'll have a Q&A portion at the end for Eric to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us here. As you come in, let us know where you're tuning in from in the comment section. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist, and we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. Hi, Carol. I see you out there ready to chat with our viewers today. For anyone just coming in, welcome to our virtual Lunch and Learn, Rockwell Automation ArmorStart product family, variations, and troubleshooting. Today's session builds on an earlier session that Carol actually led for us, ArmorStart Connectivity. And you can find that session in the virtual Lunch and Learn playlist on our McNaughton-McKay YouTube channel. Our specialist, Carol Weber, will be looking for your questions as you have them in the comment section, while Eric Dixon reviews and compares different ArmorStart models and their varying applications and troubleshooting techniques. We'll also have a Q&A segment at the end of Eric's presentation. And if you'd like to reach out afterward, or if you have further questions for Eric, you can always send us an email at macandmaclive@mc-mc.com. Be sure to let us know which session you attended, and we'll direct your questions to Eric. We'll have that email address on the screen for at the end of the presentation for you as well. And it looks like we have a number of viewers with us now. So Eric, I'll pass it over to you.
Thanks, Rachel. So this is a build on Carol's presentation that she had on April 7th. We're going to go over some different variations of ArmorStarts and talk about some applications and some troubleshooting tips with the ArmorStarts. So the main ArmorStarts that we're going to look at today are the ArmorStart LT and the ArmorStart STs. So I guess the big question is, why an ArmorStart, right? So the ArmorStart has a simplified package, essentially. It also has simplified installation with the quick connect on the bottom of the ArmorStarts, and it's mainly a common design between the ArmorStarts. So a similar footprint for the different types of ArmorStarts. With the ST, you can have isolated safety. Not to say that the other ArmorStarts can't have safety rating, but you have to do the safety back at the power distribution panel, where with an ArmorStart ST, you can have safety at isolated ArmorStarts, so you could do things like zone control. Another thing that the ArmorStarts have is a thing called device logics, which is sort of a simplified program that can exist inside the ArmorStart, where you don't actually have to use a controller to do simple commands. So like maybe some sort of timing control or different start and stop inputs. So let's go over the ArmorStart LTs. And Carol went over this quite a bit in hers. A couple of unique things with the LTs that are unique to it compared to the ST is that the I/O configuration is essentially 6 inputs or outputs. They can be configured either way, whether you want to have sensors going into them or if you want to fire something like a pilot light or something. So that one's sort of unique with the LT. Basically, with the summary, some of the things to take into note is that with the VFD portion of the LT, they're rated up to 2 horsepower. With the across-the-line starter or reversing starter, they're up to 5 horsepower. One of the other unique features that I want to point out and I want to show is that one of the things that you can have is an internal source 24-volt DC power supply inside the ArmorStart. Now this is kind of unique because you only really need to distribute 480 volt power to the ArmorStarts. This has its features and also has some of its issues with that, and we'll go over that. The other thing is I want to point out here is the local lockable motor disconnect. And the thing here is that it is a true disconnect. It doesn't have any circuit protection in there. And that's one of the features with this that I'd like to talk about and I've seen issues with in the past and would like to discuss some of those troubleshooting techniques and things to consider when applying this ArmorStart. And the last one here is that it's UL listed for group motor installation. So group motor installation, if you're not aware, was a design that was made I think back in the 50s in some of the textile plants down in Carolina. And what group motor installation was for small horsepower controllers, you would have one individual branch circuit protection feeding multiple motors downstream. So the idea was if you had a large enough wire and you were protected with that upstream, then you could have multiple motors off of that one given feed. This goes sort of against what your traditional NEC 430 circuit looks like, which you have your individual short circuit protection, you have your individual disconnect, you have your individual motor controller, and your individual overload protection. So all four of those particular elements are your typical motor circuit. Where group motor installation, you take that short circuit protection and you have one feeding multiple motors. So one of the things when you're thinking about the ArmorStart LT is that they can be somewhat limited because of the lack of the dynamic brake. So this can cause issues or completely rule out certain applications. Typically, when you have a lack of a dynamic brake, you have to slow your application down or inertia applications, right? Otherwise, you get over voltages that can occur if the power can't be burned off, essentially. Or certain applications can't be used at all. So that's one thing to think about with the ArmorStart LT. The group motor installation and the fact that there's no short circuit protection in the LTs can cause some issues, particularly if during startup something gets miswired. The problem is that you can have an issue where a short might have occurred or during miswiring of the initial startup, and you can have multiple motors essentially on this one particular breaker that trips, and trying to track down that particular fault becomes an issue. The other thing, and while I talked about it as being a feature with the integral 24 volt, the 24 volt also pulls up your network on the ArmorStart. So if you have a lot of ArmorStarts with this particular feature, and you're trying to bring them all back online, if say an e-stop were to happen or some other feature, somebody throws a disconnect or something like that, it can take quite a bit of time to bring the network back up online with the integral 24 volts. With your traditional 24 volt where it's distributed, you have an unswitched 24 volt that keeps the network and your inputs and outputs up and running. So those are just a couple things to think about when you're looking at an LT. So here I'm kind of showing the group motor installation issue. As you can see here, it's a straight disconnect, no short circuit protection or anything like that inside of there. So let's just say here, we're only showing 3 ArmorStarts here. But if we have one of the motors that has an issue, whether it's during startup or if it's during running where a motor actually has a short or something like that, this would trip the branch circuit device up here. So if we're only looking at 3 motors here, it might not be a big issue to try and track down where that fault is. But if there's something like maybe 20 or 30 ArmorStarts on a particular circuit, this becomes more of an issue. The only way that you would be able to do that is to turn each ArmorStart off, put on the main disconnect, and then progressively go through each ArmorStart, turning them on until you find out where that particular issue is. So just something to consider when you're looking at an ArmorStart LT. So the next, we'll go to the ArmorStart ST, which has a lot more features. There's a standard version, which I said you can do safety with. It just has to be done at the power distribution panel. They also have a hardware version, which uses safety I/O in conjunction with the ArmorStart. And then there's a network-based safety, which doesn't require safety I/O along with it. It also provides some nice features as far as actually providing safety I/O that you can hook up possibly a light curtain or an e-stop to the ArmorStart and eliminate the need for safety I/O actually in the field. So some of the differences, we talked about the safety. They have versions that have 4 inputs, 2 outputs, or 6 input versions. These are not configurable. So when you buy these, they have to be hardware set. So when you purchase the ArmorStart, that unit is limited to that. The nice thing with the VFD version of the ST is that there is a dynamic brake connection that's already in there. So inside the ArmorStart, I'm not sure if a lot of people know this, but it's actually a PowerFlex 40 that's inside there. So when you get the dynamic brake, it's already built into the drive. Essentially, what they're doing there is just providing you a connection for it. So it's kind of a nice feature to always have the dynamic brake connector on there. Also, the group motor installation exists for these ArmorStart STs, but the difference with these is they actually use a motor circuit protector as the disconnect. So there is short circuit protection on there. So where you have the issue with the LTs of being a straight disconnect, this actually provides you short circuit protection for the device. And this is sort of the progression of the ArmorStart and how we got to the ST. Essentially, the ArmorStart was released in 2009, was a device net only version, was non-safety, then eventually they came out with a safety version that was hardware based. Eventually they moved to the ST. We got a safety version, but it was hardware based only. And then just this past, well, I guess it should be 2 years ago, they released the network-based. And you could tell the difference between the hardware-based versus the network-based based on the red portion here. This is the I/O board, that's the safety I/O board inside of the ArmorStart. As we look at it here, we see the red on the I/O there. You see the user safety I/O on the bottom here. This is actual I/O that can be used as as safety IO. So like I said, you could hook up a light curtain to this and get catalog 4, SIL 3 safety on it. The other thing that I wanted to show in this particular slide is that they're a modular base. And the main reason for this is we'll come up to it in some of the troubleshooting techniques on what we have here. So just know that the control module can be removed from the base for troubleshooting reasons. But this shows some of the connections as far as for the ease of installation. And if you notice, almost all of the connectors are a different type of connector, and that's to prevent from any miswiring for the ArmorStart. There's one exception that I'll point out here is the safety IO, and I also want to point this out because this is a one of the troubleshooting things. Both of these are micro M12 connectors of the same type. So common problems that we see. Motor will not spin. These are calls that I've gotten a number of times. VFD can't be programmed. The safety contactors won't pull in. Over voltage on the VFD, power light doesn't come in. And it turns out that 90% of these problems is due to lack of power, whether it be the 480 or the 24 volt. And there's a couple things to be noted here. The big one is with the VFD and it not being able to be programmed. So like I said, it's a PowerFlex 40 inside of the ArmorStart. So a lot of times, if the 480 volt power is not on the ArmorStart, only half of the parameters can be seen. The 24 volt will power up the board for the ArmorStart, but it won't power up the VFD portion of it. So you'll get to maybe about parameter 100, which has a lot to do with the ArmorStart programming, but not necessarily the VFD portion of it. So a lot of times if we see this issue, it's the 480 volt that's not being on there. Another thing to note is the one with the power light. So the power light is actually based off of the 24 volt power and not actually the 480 volt. It's a little confusing, but a lot of times you'll see the power light on or the power light won't be on, and you'll think that power's all good. That doesn't necessarily mean that the 480 volt power is to the ArmorStart. So the light can be a little bit deceiving. Just know that it is based on the 24 volt power. So a couple troubleshooting techniques, right, that I've come across in the past. The easiest one to do, and we see mistakes that happen, right? So these, a lot of times, particularly during installation, people are turning on and off breakers. They're adding pieces of equipment here and there. The easiest thing to do is to test to see if there's power on the actual terminals. So the little access panel on the front of the ArmorStart has always existed there. It's easiest to take that off and measure power on the terminals behind it and verify that the power is correct there. So even underneath that little access panel, there's a wiring diagram that it shows there with a sticker, and it shows what power should be on which particular terminals. And I've seen issues where silly things happen during installation where cables don't get plugged in correctly, or the circuit breaker gets thrown back at the panel, and that's the easiest thing to check. The second thing is I told you that the control module can be removed from the ArmorStart. There's a pair of fuses, and particularly with the one with the source break, there should be a total of 4 fuses. It doesn't hurt to remove that control module and test those fuses to see if any of those are blown. So some of those fuses handle things like the outputs, but they also handle things like the contactor coil, if it's a starter version, or the source brake, if it's a VFD version. So it doesn't hurt to check those fuses, and it's an easy enough thing to take off without dismounting the ArmorStart from the fence or its mounting stand. Another big one, particularly with the hardware-based safety version, is to double check the input and output cables going into the safety. Like I said, these safety connection points are both M12, and with the hardware version, they're sourced from the I/O block, so they're both male connections. It seems silly, but they can get reversed, and a lot of times I've seen where they get reversed and they think the ArmorStart is bad, but essentially it's just a mix-up of cables. One of the easier things to do when you pull in the safety is to listen for the contactors, right? So, and that goes along with other starter versions of the ArmorStart. If you can hear the contactors pull in, then we have a place to start troubleshooting. And one thing to note as far as applications go for the hardware-based ArmorStarts is to use the bipolar outputs for safety hardware. I've seen multiple applications where customers try to use standard safety input and output blocks, and it becomes an issue. It doesn't have enough power to pull in the redundant contactors that are inside of the ArmorStart. So that is a note to keep in mind when you're selecting an ArmorStart safety version. Now for the overvoltage we talked about. Overvoltage happens in a VFD when there's too much power being regened into the VFD. So some of the things for the ArmorStart that you might want to check if you're getting this overvoltage is to see if the dB resistor parameter is even enabled. Sometimes it isn't, depending on how the build is done for the ArmorStart. One other thing to check, particularly when you're getting overvoltage, and you know that the dB resistor parameter is enabled, is to lower the dB threshold parameter. And essentially what that is that there's a particular voltage level that the dB kicks on, right? So if it spikes too fast, you can trip before the transistor can actually burn off enough power on the resistor. So lowering this parameter can help. Now, I say this with caution. If you lower it too far, you can end up burning up the resistor or doing some other damage to the equipment. So I would only suggest, if you're continuing to get overvoltage faults, to only lower this by about 5%. If you're still having issues, then I would suggest contacting your local drive specialist and see if they can assist you further in your application. So the real reason some of these suggestions as far as troubleshooting go seem pretty simple, but the real reason we talk about this is we kind of live in a rip and replace society where it doesn't work right away. We decide, okay, we need a new one. Well, the problem with an ArmorStart is it's not exactly a short lead time product. Typical ArmorStarts can have a lead time up to 8 weeks during multiple projects, and if multiple customers are ordering for different projects, it can be anywhere between 10 weeks. So it's typically a hard device to replace. And for the most part, they're non-returnable and have restocking fees. One of the other things is for simple troubleshooting techniques, right? Most of these fixes don't require the ArmorStart to be taken off the fence or shipped back to the distributor or even Rockwell to take a look at. So a lot of these simple testing techniques can be done with the unit still mounted. And it can lead a sour taste, particularly for you guys out there, with the product. And it can be simple things that you could check. And like I said, during installation, a lot of things are happening, so they can be simple things to check that maybe something silly happened. And the main overall reason why to do these little troubleshooting techniques is the overall cost. The product's not exactly the cheapest product. It costs our companies, both of ours, to do paperwork and do shipping and all of that. And to do these simple things might save time in the long run, save costs in the long run, and help us all out in the end. So that's basically what I had for today. Just some simple troubleshooting things. Obviously, if some of these things don't work, McNaughton-McKay is here to support you, and we're here to help you out. So that's all I had. So Rachel, I'll pass it back to you.
Thank you. Absolutely. Thank you, Eric, for that presentation. We don't have any live questions in the chat at this time, but I will give a few minutes here at the end for anyone that has follow-up questions for you. So now's the time. If you want to drop those into the comment section, feel free. While we wait, I just want to reiterate that you can reach out to us even after this live stream is ended at the email address there on your screen, macandmaclive@nc-nc.com. We'll be sure to get your questions passed along to Eric, who can respond to you directly. All right, I do not see any questions coming in. So I'd like to thank you, Eric, for a great presentation today. And thank you to Carol for being our resource out in the comments section. And thank you to all of our live viewers here today for your time. We hope the session was informative and engaging for you. Remember to subscribe to the McNaughton-McKay YouTube channel for more industry content, and we look forward to seeing you live again soon. Thank you, everyone. Have a great day.